welcome to this code night. We're going to spend this night talking about Go, and what we're going to do is basically we're going to have 3 sessions of 20 minutes each. I'm going to go first, and I'm going to talk a little bit about like an introductory Go stuff, talk a little bit about like what I think is cool about Go, and then these people are going to provide some excellent perspective. And they have years of experience. I have like months, 2 months to be specific. So I'm very new into this, and I reserve the right to be wrong. With that said, if you Google Go, you might end up with a different result. If you Google Golang, you get more specific results.
Yeah, but I'll make a quick point here. It's great that the presentation matches research.
Oh yeah, happy accident. Yes. Okay, so my talk is kind of outlined like this. I'm going to talk a little bit about simplicity, talk a little bit about the Go ecosystem or stack, a little bit about language. I'm going to try to do a little bit of demoing, but some workflow stuff that I think is nice with Go, and then a little bit more about the language. I have about 30 slides in 20 minutes, so it's going to be pretty fast. But we have lots of questions, room for that at the end. I will refrain from talking about like subtleties of the language and going into like semantics and stuff like that. There is excellent resources online available for this. So with that said, if you have questions, of course, ask them. But you can find mostly everything you need with regard to this here. And so I want to open up with a simple premise. What I think, which is so great about Go, and is that it does impose constraints on your programming. Which kind of invites you to think about what is it that you really want to do here. Because it's a very simple language, in essence. That doesn't mean that you can't do really cool stuff with it. It's just that you'll realize very quickly that if you're very used to certain constructs, you'll find that these are not there. And maybe you'll get angry at Go for this, but you shouldn't, right? It's just different. And in case simplicity isn't really the best thing in the world, I invite you to watch this simple presentation by Rich Hickey. It's called Simple Made Easy. And he gives a very compelling argument why you should favor simplicity over many other things, and why maybe simplicity is hard to achieve. So do watch this, because I think it'll give you a good entry point to the whole Go stuff. And so with that, I would like just to say that Einstein is said to have wrote this very complicated thing in his own little way. And basically what he was trying to say was that we should strive for simplicity. But we should be very careful to not oversimplify and lose sort of like the capture, the essence of what we're trying to do. And this is sort of what I think Go can be really good at, capturing the essence of what we would like to do. And in case of about Linus Torvalds and his talks about what is good code, he refers to this as good taste. And you can look this up as well. You can find an excellent interview with the curator from TED, Chris Anderson. He talks to Linus about like what is good code, and he gives a great example of what is good taste. With that said, let's take a look at some Go code. So I purposely just jammed the Go code into the slide to kind of show a feature that's sort of built into the way we do Go code. And that's that we have this tool that sort of does this for us. We don't really format Go code explicitly. It is sort of built into the system that you're kind of forced to, well, you're not forced to use this tool, but you should. And it will basically make it so that every Go program has the same sort of formatting, style guide, if you will. And there is an interesting aspect here, which is basically that it actually added import statements for external packages that we consume in our code automatically. We have to maintain those otherwise normally, so the tools can kind of help us do this more practically. And if you use ReSharper and stuff like that, you're very used to this sort of things, and they have support this. And this is like a very simple Go program which has a it selects a random integer and it just prints it to screen. Like, does anyone want to raise any questions about this? Right?
Yeah, I have a question regarding the assignment separator. Is it like colon? And
yes.
equal?
So that's not an assignment, that's actually a declaration. And it's an implicit type inference. So there's two ways you can declare. You can say var, and then you can say the variable and the type, or you can do that. So that's an implicit declaration. So it introduces the name n, and it will have the return type from the return value of this function. So it's not assignment. I saw,
Not only assignment.
like not only assignment, right?
So it's basically like a C# var.
Yeah, similar. Yeah. And the first time I saw Go code, and this was a very long time ago, I was very like appalled that what was colon equals sign. What is that? Yeah. Yeah. Okay. Cool. I did not know that. But I don't care. I really don't. This is how I feel about this. This is actually from Insomniac Games coding guideline. That we can spend a lot of time discussing how to properly format our code, but if we surrender that debate to a tool that just does it for us, we just follow the tool and do S, and we can focus on other things. And this is sort of like one of those things I think is nice about Go, that we can ignore certain things, certain conversations, right? There is no debate about where the squigglies go and where the indentation is. It just happens. And the language is sort of, I'm pretty sure they thought about that very early on, because there's lots of cool research on Google about this in terms of C++. They have very extensive tools for doing this with C++ as well. But enough about that. Let's talk a little bit about like the entirety of Go, which is kind of interesting. It's been around for 6 years. The 1.0 release is not that old, I understood. The entirety of the Go runtime and compiler and infrastructure is in itself now also in Go. So this is kind of new, which is interesting in some ways. They have a very, very good GC, which basically has no pause times, which is kind of amazing. And they did some amazing work in the 1.6 release to improve this performance even further. So there's a great talk about that you can look up. It's really cool. And there's a beta version now for Go 1.7 out, which they're going to introduce a SSA backend, which is going to improve performance for compiled programs, just because they can do more and better optimizations. This, of course, means that we need a Go compiler to build Go, and if you don't have one, you need a 1.4 Go compiler to build Go on a system and stuff like that. So there's a bootstrapping challenge there. Cool things about Go, you can build and run on Unix, Linux, OS X, Windows, so it's cross-platform, which means that you can compile your program on Linux for Windows or the vice versa, because they give you that. And there is no intermediate representation, and I think that's an aspect which is important, and I'll come back to this later. But that essentially means that Go does not compile to bytecode; it compiles to the target framework. Target architecture directly, and it will yit machine code, which means that we have excellent startup times and we have excellent performance, in essence, from these systems written Go. Go programs are also self-sufficient, and by this I mean that they don't have dependencies on external libraries, right? They compile it as a single static binary with all the dependencies baked in, and they are they cannot collide with different versions. So if you have an older Go version and a newer Go version, those are like independent binaries. They don't know about each other. They don't know about their dependencies. They're just binaries running in the system. Which, when you come to like deployment situations, when you need to deploy applications, you need to run software in different places, that can actually be a really nice feature, right? This also means that the Go binary is a little bit larger, but they're by no way incredibly large. A simple Hello World program is about 2.5 megabytes, which is like, yeah, that's big. But then you remember, like, there is an entire ecosystem in that binary, right? There's a GC and a runtime and all that, and it will just work. And I find that to be tremendously powerful, actually, to have something like that. And remember, like, there was no compiling to bytecode, right? It was machine code, which opens up the doorway to assembler, right? And most of the times we don't really need assembler. But there is hardware in the computer that can do some things extremely well. And some of that is single instruction, multiple data. And some of that is hardware acceleration for stuff like encryption and stuff like that. And these things are generally not available to you from a managed environment. You don't get to use those things. But Go actually has a nice little place where you can actually add and open up the hardware and get at it and do things in a very low level. And there are various operations in like the math runtime library that's actually implemented with assembler for performance reasons. And also, right, so the Go memory model, it comes with its own set of rules for concurrency and stuff like that. But again, they're kind of trying to tell you that you probably don't want to think about this. And you probably want to take a simpler route. And that's kind of like you'll find this theme everywhere we go in Go code. It's going to be like, don't be clever. Like, just trust in these primitives that we have for you. And we'll talk a little bit about what those are. And to me, Go is an ecosystem. It's a lot more than just a language that I can use to write software. I can use it to bootstrap environments. We will see cross-compiling examples or transpiling examples where Go is used as a target for things. And since it delivers like the static binary, it has lots of nice tooling to do verification and stuff like that. It's really, I think of it like an ecosystem, not just a language. Okay, so an example of something we can do in Go and how they deal with certain constructs. I really like this. There's been some discussion about having this in C#, and basically what it is, it's a slice of data. Are people familiar with slices? Yeah. Right? No, not in JavaScript, but in the idea is basically that it represents a subset. Like there's this array segment, which is sort of like a poor man's slice in .NET Framework. But in Go, slices are kind of everywhere, and they're kind of built into sort of things you can do. And here we see that other type of declaration. We can say like, okay, we declare something called Q, we give it the type name comes after Q, and we say, okay, this is a slice. And we say that by leaving the size of the array unspecified, right? So it's an empty slice. And then we do, we can print this value, right? And this is an uninitialized value, just created living somewhere. And then we can say like, let's append 1 to this slice. And it will just say, okay, fine. I will allocate some memory for you to back this thing. It will append the value that you want into this thing, right? So the slice is a dynamic array, like it's an array list, right? So the slice provides kind of one of the fundamental like collection types in Go. But it's so much more than that. It has lots of nice syntactic features and other support for doing things with it. So slices are nice. And the best way to think of it is like it's a segment of memory. But it can also be uninitialized and initialized as needed. And here's just some more examples of what we can do with slices, how we can slice the slices, right? We can ask for portions of the slice. We can say, give me everything from 0 and upward. Give me everything from 0 to length. Give me everything skipping the first element. Ignore the last element. Give me between 1 and 2. Stuff like that. So we can kind of grab portions of things. And we do this without copying, which is kind of nice. So we can give a portion of something to someone else. Yes?
I understand that's a list, right?
Mm-hmm. Yeah.
That would be a list.
Yeah, definitely. Yes.
Yeah.
Yes. And this is like, yeah, we'll get to this. Yes.
If I give a slice to someone else, that slice will not be copied, so it won't be
Precisely.
But will the place where I give the slice, will that still know anything about the original location? I mean, will it automatically re-index the elements? So if I give it 1 to okay, you're nodding, so.
Yes.
So the base, yeah. So you change what 0 means. So when you say give me a slice between 1 and 2, then 0 means the second element. Things like that. And it's shared memory unless you explicitly copy it and stuff like that. To me, Go is a systems programming language. It means it tries to be efficient about the way you manage bytes, basically.
So immutability is not a thing.
No.
No.
It is not.
No.
Right.
And so there's this thing called idiomatic Go, or like Go proverbs, which is sort of like another nice lecture by Rob Pike. He talks a little bit about like what is typical Go code. And back before I showed you an example where we took kind of like an uninitialized list, basically the equivalent of a list which is a null reference, and then we said add 1 to it. And that's sort of like what Go kind of expects you to do. Like your basic initialization is just 0 or null, right? There's no default instantiation. It's just an empty blob of 0 bytes. And so that's where we go from. And the cool thing about Go is kind of like they say that the empty value for a string is the empty string, not a null reference. So we kind of get the sense that we're always dealing with values, bytes of values, right? Which is kind of nice. And this is kind of where I think Go is a testament to simplicity, because that's what it is. You're not going to find some weird case where, oh no, that's actually a reference type, it's not a value type, so I can't do that with it because I have to go through this other construct to deal with that special case. There are very few of these examples in Go, which is very nice. Because you find yourself sort of like in a situation where, well, I should probably be able to change this into that, and it will just work, because you'll recognize the patterns, because they are similar. Here's an example of a typical type declaration when you're introducing user-defined types. And so you always introduce your own types by using the type keyword, followed by what kind of type is it? Well, it's a struct. And then you say, OK, I want a couple of members here. And you append the type information after the name of the member. And then you can put in metadata, like attributes in .NET, right? And these are basically just string key value pairs that we can put into our structs. And this is where kind of reflection becomes interesting. And of course, this is some sort of annotation to tell us something about if we were to serialize this thing, how would that be done with JSON, for example, right? I'll say something about visibility. There is two types of visibility in Go. There is package private and public. That's it. I think that's a good choice. And the way it's done is by capitalization. So if the member variable has a capital letter, it's like Björn, clench, no! It's a public variable. And if it's not, if it's a lowercase initial, then it's a private variable, package private. So everything within the package can access it. If you need to change that, it might, be painful, but you'll be happy to know that there is a refactoring, rename tool in Go which can do that for you. So.
I also want to mention, for those coding in foreign languages, even though I don't recommend doing that, this works with any Unicode character that has a lowercase and a uppercase. So you can do this with Chinese or Japanese characters as well. Even though I would not recommend it. It works.
Also an uppercase.
Yeah. Exercise for the reader, right? OK, so now we're getting into kind of the weird stuff with Go, that they even give their own names, right? So clearly, these are not coroutines. They are Go routines, right? So if you know about coroutines, these are not that. These are Go routines. But they may be reminding you of something called coroutines. And it's their idea of a task, right? So let's go. I'm going to do a lot of back and forth between .NET and Go, because I know that we have that in common. Go routines are like void tasks. They don't have return values, right? They just go off and they represent some sort of asynchronous work. And this is an example of where we say there's our main function, we say world, and then we say hello, and it goes in here and it repeats something, but it does it with a sleep, so it's very likely that we get hello world, right? Yes.
I want to point out, if you actually run this code, it will say hello, and then your program will end.
Oh, interesting.
When the main Go routine finishes, the program shuts down, regardless of the status of other Go routines.
Exciting.
Which means when main returns, you will still be sleeping. Which means the say,
cool.
You will never stay awake.
Because this is, I think, an example from the their tutorial they have online.
You would have to sleep at the end of main.
Cool. Okay, so it's like background threads then, right? So that's important fact. Yeah.
It's
Okay.
really important because
Yeah.
a lot of beginners get confused with why does my Go routine not run?
Yeah.
So.
So what would you do here, though, basically? What would you basically do to keep it alive?
In a real program, you would have a wait group.
Okay.
That says that I'm running 5 tasks.
Yep.
Then when done, it's called 5 times.
Right. So there's
the wait would return.
So there's a concurrency primitive called wait group, which basically can help us orchestrate some of that.
Yeah, because we would like decrement the number of waits to do,
Yeah.
and then we would have like in the last line wait
Would
group
be wait.
would be blocking,
Yeah.
blocking wait until it's finished.
Cool. So what we also have in Go is another primitive called channels. And those are, I like to think of them like queues, because that's what it is. It's a place where you can put in work, and at the other end of that channel, you can receive that work. And channels can be bidirectional. But for me, the idea is basically you set up a flow. Have anyone worked with TPL data flow? Right, so this is similar to TPL data flow in some sense. Basically, what we do is that we have this special syntax for putting things into a channel, and we have this other nice syntax to getting things. No, that was send, and then we have this way from receiving. So we will be blocking here, and then we're running these programs here over here, and they'll be sending the results back. And here you also see an example of multiple return statements you can actually do, which can be very nice sometimes, to be able to return like a tuple from the function.
It's important to note that it's not actually a tuple, so it will return multiple separate values.
And the compiler will be very picky. It'd be very, oh, you're not what you said here. That was different from.
But that is like a language construct from multiple return. It's not pattern matching.
No,
Correct.
precisely. Yes.
Which means you keep your strong piping and everything.
Well, you can do that in pattern matching.
True. More annoying.
Cool. I was supposed to do a demo here. Let's see how we fare with that. Hello. There we go. There we go. Okay, this looks like a Go workspace. Okay, that's almost readable.
Just do command enter.
I see. So what I'm doing here is I'm setting up something called the Go path. And you need to do that. You need to kind of set some environment variable to tell you kind of what is your origin of what you're doing here. So I'm doing that. And then I'm going to open Atom. And I'm using a tooling called Go Plus. And it has a lot of the cool tools that people have built around Go, the ecosystem, to I think, really improve work and workflow. So here we can see kind of a live running example of, like when I save the file, it is putting that import statement back there, because it's realizing I'm using it, right? So I don't have to think about that. And I think that's kind of interesting. But what I think is kind of more interesting is sort of like the way Go works. It's kind of like it allows me to treat Go very much like a scripting language, in the sense that you can run stuff very easily, right? It is a compiled language. It compiles a binary, but the way it does it is very quick and kind of unobtrusive. So you can kind of get away with some of the scriptiness. And so here I have this very simple stack that I've written. And I wanted to provide like testing for this. Then the Go tooling comes with sort of its own basic version of some test framework. It's very basic, but it's all I really need. And what I like with this is that I can get like kind of real-time code coverage as I'm doing this stuff. So let's say I didn't cover that case, then Go will kind of, it was automatically, oh yeah, you didn't do that. And I actually went and run my code now. So it can be that quick to kind of iterate on the result and see things happening. And this is a workflow that I find to be very useful. I like to kind of have very rapid iterations. Now this is a very simple case. But when we stick to very simple things, these things become very possible. And so the idea here is, of course, that we stay in the simple land. We try to minimize our cross-dependency. We don't try to do very advanced stuff. We try to keep them as apart in a way which allows us to do these things. And that's kind of where I think the thinking comes in. We kind of need to plan a little bit to get this, but it's very nice.
I have a question here.
Yep.
What is that? Type stack struct data empty array of interface curly brace.
Where are we? This. Yes, that's
the interface curly brace.
Yes, it's the equivalent of the empty interface. It's like an object.
Okay.
So this just means accept anything.
Right.
So any value we put in, we will carry not only the value, but also some type information. So we can do a safe cast operation to get out. It's called type assertions in Go. But it has a way for us to deal with that. Remember, there are no generics in Go, right? There's no polymorphism, type polymorphism, which is in many cases fine, but also very annoying sometimes. Yeah.
I have a question.
Yes.
Very fast. Imagine that v is integer, right? And you kind of push it on stack.
Yep.
And then you need to kind of box it in an object or something
Yes.
general.
Yep.
But when you get back, the Go should remember that it was integer.
Yes.
So it is boxing in a way, right?
Yeah,
So
yeah,
it
I
needs
think
to
so, yeah.
type and
It's the exact same as C# boxing.
Yeah.
Right? Okay. Exact same way it works.
It's very efficient, though, in the sense that they kind of boast some impressive performance numbers. It's a very simple approach to it. And I can't say to what the compiler is doing or not doing, but I have the feeling that they kind of have an idea of how to kind of do away with the overhead under some circumstances. Because
They used to,
Yeah.
actually, but they did away with that.
Okay.
They used to, so they use 2 pointers.
Mhm.
So that's 2 and 64s for the interface.
Yeah.
They used to, if your type fit in an N64, not box it, but just don't point to it, put it straight in.
Mhm.
But it did away with that because it was quite complex
Yeah.
too. In the compiler, it didn't really improve performance at all.
Mhm.
So it's always boxing with 2 pointers,
Yep.
one to your type and another to your value.
Yep.
And that's it.
And also you can kind of see here, I get some like annotations here is kind of interesting. It says like your comment here, which is my documentation for this function, is wrong. I should be using this format here. And this is from a tool called GoVet, I think. And it enforces certain style guides. And we can kind of do stuff like go doc, what is it called? I want to call it demo stack, I think. No. Like that? Oh yeah, cool. So we can ask the documentation tool for information about what we have, and it will give us kind of this summary here with information about, yeah, this is what we have and this is it and stuff like that. And of course, these tools can be used to generate HTML pages with very nice documentation. Okay, cool. So there's no parametric polymorphism. That's a funny word. That means that we cannot have generics in Go, like the way we do with type parameterizations in .NET Framework, right? There are a couple of generic constructs, and those are built into the language, and those are for the slices, the maps, the append things. So they were treated very specifically to deal with those cases. And for most situations, this is fine. But then there's this other thing called Odin. This is for Frederick, right? Odin is the equivalent of which F# is to C#, basically. And it's actually a Swedish guy who's working on this, and it's a very young project, and the compiler is written in Haskell, and it transpiles to Go. Yeah, and it's I just took a brief look at it, but it was really cool because you have all these nice functional aspects, and you can call any Go code from it. But you cannot do the opposite, right, as easily. It's the same thing with kind of C#. You don't really call into F# code. You call into C# code, generally, right? if I remember correctly. That's sort of like it's not that they can't do it, it's just that it's different. There's also Go Generate, which is a built-in tool for doing code generation, right? Which can also alleviate some of the problems with not having parameter orientation. I'm going to speed up a little bit there, but just get through these last things. Package sort, generic sort function. Interesting aspect of the way kind of Go interfaces work, or like what we do, is that I feel as if we inverted the thing. We took the internals of the sort algorithm and kind of exposed them in the terms of an interface. So this interface is actually called interface in the package sort. And since interface implementations by the compiler are implicit, if you just have these three signatures on a struct or a data structure, right, you can sort them. And the assumption is, of course, that you can provide a less than comparison. You can provide a swap to positions in a random access array, and you can provide the length of that array. Then it can provide the sorting algorithm for you.
So this is sort of like type classes and
yeah, something like that. I don't really know type classes, but if you say so, I totally believe you.
But didn't you go to Gothenburg?
Oh yeah, I did lots of Haskell, but we never dug into kind of stuff like that. Like we had abstract data types and like recursion and currying. But I think this is kind of cool. I found it on Reddit, on a thread in Reddit, and the immediate kind of takeaway I got from it was like they took the algorithm and then kind of inverted the constraints on it. And they say, if a collection implements these things and provide these properties, I can sort it. Cool. A couple of people who's using Go, so it exists, right? So there's lots of fancy names for people who are using it, right? There's a tremendously long list. And Google, they start out with saying like most of the projects that use Go internally are classified.
How would they know?
Yeah, exactly. And I found this tutorial to be good as well. It has it's a short, there's lots of like shorter examples you can follow with lots of good advice based on like how would I structure my Go program, how would I do things in Go and stuff like that. So it's a good reference to check out. Yeah. I was listening to this presentation by one of the German designers. He talked a little bit about the history of Go, the evolution of Go, and he made this like I hope it was him at least. He made this reflection that it takes about 10 years for something to become mainstream. And Go is gaining a lot of attention, and clearly there's a healthy ecosystem. There's lots of conferences and a lot of stuff is happening around Go. And in a couple of years, it could very well be like a big player, something that people are actually using and looking more into. So I think now is a great time to take a close look at like what could Go offer. And that's it. Questions regarding what we just did? Otherwise, we'll just switch over to the next speaker.
I have a question. You said it doesn't compile into bytecode.
Yes.
But that actually means that it cannot use one of the advantages of JIT compiler when you can
Yes.
consider
Yes.
The real processor what you
Yes.
need to compile for.
Yes.
So like, does it affect the performance?
So this is my own opinion about it. So a JIT compiler has a startup cost, which means that there's some latency involved in starting up the program. You don't have that with Go, which is nice. It's true that if you do sort of like runtime profiling optimizations in JIT compilers, like some of the more advanced stuff that Facebook did with their hip-hop compiler was kind of essential to getting better than C++ performance from their systems, right? You can't do that unless you can do some sort of profile-guided compilation stuff. However, I feel as if the general performance benefit of doing a proper SSA-backed compiler, which you're doing now, is going to give you really good performance. And using bytecode is an abstraction in itself, which is not free. And so there's things that we can do with the Go ecosystem, with the assembler stuff, right? Which kind of opens up optimizations, which are, unless you own the VM, closed for you. So there's definitely trade-offs here and different aspects of it. What I really like about Go programs is they are dependency free in that they're statically compiled binaries that I can run and that they start up very quickly. So if I want to write lots of tiny command line tools to do simple things, I don't have to wait for them to warm up. Cool. Now Peter is going to talk about production stuff.
Yeah, so let's start. So I'm Peter. You can find me on the internet as Peter Helper. And I work for a small consultancy called Athiga, where I currently work for a client called TV4 in their infrastructure team. And I came to TV4 for a couple of years ago, and their main infrastructure was already on Heroku. They were running a few separate services. We wouldn't call them microservices. They were fairly large services, both hosted on Heroku, as I said, and hosted at their old trusty hosting provider, Base Farm, that do physical machine hosting. This is the workflow that we moved over to, where we work on GitHub like everyone else. We switched over from using their own internal Jenkins machines into running Travis, which is a hosted CI service that will deploy to Heroku. And in June of 2014, I decided that it would be nice to introduce Go, that I had been experimenting for quite some time at previous consultancy gigs and also personally. But we had a small service, one of the few services that were actually small and only had 2 endpoints, where I saw it would be a good fit. And I think that is a very good way into an organization that has many developers, where you can't really come in one day and say oh, well, now just choose another language, a brand new, well, not really brand new, but a language that none of the other developers were acquaintances with. And doing the switchover for that small service took a couple of days to write the replacement and deployment, and we used the same strategy, push to GitHub, have Travis build it, and deploy it. We already had a lot of production traffic going into it, so all of the page views were already touching that one of those endpoints, because it did statistics for articles read or videos started and so on. So it's not really that much of a high throughput system, considering we are in Sweden and almost no systems are high throughput. And and the main issue was it was written in Ruby, which is not one of those fast languages that we hear about, which is usually fine. I mean, Ruby has done a lot of good things for a lot of organizations. The Rails framework has been great for content websites and a lot of companies. But we wanted to have a different result than having this hard to maintain. I think it was a very long time since anyone worked on that service. It had just gone into stagnation, and we saw some performance issues. Not any major things, but we wanted to at least understand the code, and replacing the system was easier than just figuring out what it did. As I said, it isn't a huge service by any stretch of the imagination, but it's doing a couple of 100 millions of requests per year, and every the huge majority of all those endpoint requests are also writing into a database. So it's a very write-heavy service and read very seldom, as in every couple of minutes. So the writes far outweigh the reads. Yes, we use MongoDB for that service. Initially, that was just because we replaced the earlier service that used MongoDB, so we wanted to just keep parity with like how the old service worked, and see what we could do with Go. That service has now been running since 2014, and we generally reserve up to 10 megabytes of resident memory. And that is on the upper end, so it's between 4.5 and 10 megabytes of RAM that you need to run this service, which is a very nice thing to have if you're co-located in the Heroku space and you pay for small machines running on Amazon. So having all these tiny services that you pay like close to Heroku is expensive, but I mean it is cheaper to pay for the small machines than the larger machines. So we see a lot of benefit from using Go in this instance, because we can expect our like baseline small services to allocate like in the tens of megabytes. Our Ruby services might be in the hundreds of megabytes, and Java services we've seen in gigabytes. And that can obviously be tuned, but just to have that starting point where you can just write your little web service and not break the memory limits of your virtual machines. The experiment with like introducing that to the organization was twofold. I mean, initially just replacing service, and that worked well, but having other developers coming in, seeing that, well, here we have a service that we have deployed. We haven't seen any issues with it really. This is a language that is fairly simple. I mean, Go is one of the smaller end of the scale of languages. We have 25 keywords in Go. Ruby has 42. Java has more. and Scala has many more. You can make your own. But so it's a fairly simple language in the sense that there's usually a prescribed way to do something. And if you want to iterate over something, well, we have a for loop. That is also the only thing you can have to iterate over things. There's no while, there's no for each, there's no, well, for loop is also like with bells and whistles, so we can do all of those other things with it. So it's not really fair to compare it with like a C style for loop. But when we saw like this is something that was fairly easily implemented into the technology stack, because as you said, we get binaries. They usually aren't statically compiled. We usually, well, if you don't actively work towards it, you will still link to libc. But in general, you will have libc on your machine if you're running a fairly recent Linux. We have the benefit of being able to develop on Mac OS and deploy to Linux. We also have the added benefit that we don't have with other languages, that when we run on the second step, on the Travis CI step, when we get our tests green, we also build the production binary and deploy that. So our deployments are just shipping the binary file. So the machine images on Heroku is running nothing except our binary. So it's not even aware that it is Go. So we got some flack from Heroku because we're not actually telling them that we're running Go, and they want to have us as a case study. So we're running on a null build pack that, well, does nothing except start a binary. And that has been working well. and mainly due to the binaries behave well. They don't do any strange calls out to the servers, to the operating layer, and as long as you compile for the correct architecture, well, AMD 64 Linux in our case, you can expect those binaries to run, well, pretty much forever. Another service that we found to be problematic was that a service that was written at the time when ImageMagick didn't have a lot of CVEs and security issues. It did have those, but they weren't published. And ImageMagick is a great library that is hard to compile, and it is also stemming from problems with image manipulation, where most of the algorithms that do like resizing of images and so on can't really be like parallelized or limited, or there's no way to have a quota system on the library. It expects you to give it all of the cores. Well, if you compile it to support multiple cores, or the single core that it supports in the general case. We have multiple images being processed at the same time, and that makes for this issue where like the capacity of the server will be fully allocated to one processing job, and then there's 10 others coming in. So we wanted to get rid of like at least that problem. We weren't that that sensitive to the actual performance, because we generate images that then get served by Akamai or the CDN. So it's only when you request a new image that you will actually perform this job. So we figured that could we do this in Go with just the Go standard library? And as it turns out, yes. Go has very good, like in the standard library, there's a good image manipulation, like primitives, let's say. There's no draw package, or no convenient drawing package. There's the building blocks to build those packages in the standard library. So managing different types of image file formats, it's quite easy to do that from the Go standard library. We have since, well, I started with the beginning of the year just to have somewhere to start, and I just looked before I arrived here today, and we've done a couple of millions of images, mainly due to having multiple client teams doing, well, Chromecast and Apple TV and all the mobile platforms and so on, and they all want to have different sizes of images and different overlays and so on. So it's not individual images. And having this very different workflow, like Go was never really meant to do this. I mean, this is an operation that's, you allocate a lot of memory because we have unknown images, because I didn't mention it, but this image proxy takes in a source parameter from an image that is like on an unknown domain somewhere out on the internet. It downloads that image and then does the work that the parameters tell it to do. So we have issues with network latency and people in the CMS like uploading 20 megabytes PNGs for thumbnails and stuff like that. And even though you tell people that you shouldn't upload huge images on the internet for the front page, people will still do that unless you force them not to. So this has been working quite well in an area where I didn't think really Go was perfect, but it has been working quite well for us. We have a bunch of websites running through this service right now, and so far image manipulation in Go seems to be quite nice. A service, on the other hand, that has been much more well suited to how Go does concurrency is a service called personalization. But what it does is mark your favorites and the progress in your video player. And Go has a concurrency model. It stems from Tony Hoare's seminal paper communicating sequential processes. And that is a white paper from the late 70s. Erlang was also inspired by similar ideas. They decided to go another way with their actor-based model. The CSP model is, as we heard earlier, mainly concerned with coroutines or Go routines in this case, and channels. Having those primitives is very simple to reason about, because you can. I should mention another very important primitive that you can also block on a channel or multiple channels. So you can have like a fan-out, fan-in strategy, or you can have many different types of strategies when it comes to when you receive back from the channels. So you can, like in many languages, you have a switch statement, but we also have a select statement where you can select from the first arrival of a bunch of channels. And that way you can have, at least, you can have some work to do during if you have a channel with high latency, and you have a channel with lower latency or higher throughput, you can always interleave those with a for loop and a select. And these are tiny, like smaller. These are like a higher throughput service, but we see the same characteristics with deploying on Heroku. We still run fairly small machines, but we need to store more data, of course. So we store those in Redis, and binding to Redis from Go has been very pleasant. There's no specific database drivers in Go. There's a similar, like in Perl, where you have like a DBA package, like you have the building blocks, but you don't have the connector to the individual database drivers. You usually, when you write a small service in Go, one of the first things I've noticed is that you will reach for an external like database driver for the driver that you want to use, for the database you want to use. I should mention that earlier when we used MongoDB, the MongoDB tooling is written in Go. So the MongoDB driver for Go is actually the MongoDB driver. Period. So they will always be in sync because, their own tools use it. The Redis driver is well used and well tested, but it's not an official driver. And as I'm more and more getting comfortable with the language over the years, I've found that the Go standard library is very, very true to its claim that we have batteries included. I mean, it has encoding and decoding for like different schemes, like let's say XML or JSON or different crypto libraries, and you also have direct access to the AST, and you can parse Go code, and you can do a lot of those things that all the nice tools we saw earlier can take advantage of, because most of those are built into the core available standard library. So you don't need to do any fancy stuff with internals.
this is kind of cool because Microsoft sort of promised this with Rosslyn, right? That's kind of they made the C# compiler in C# to kind of open up the compiler as a service. They've been doing this for a while now, and they actually have proper tooling that actually do really cool productivity stuff already.
Yeah.
And I can't say the same really about Rosslyn. It hasn't really, not to my knowledge at least, it hasn't really taken off the same way. Because I feel as if it's quite hard to get into Rosslyn, but I feel as if the Go stuff, due to its simple nature, and it's the core domain, it's more accessible.
Yeah, I should also mention that, as we saw earlier, Go was, well, transpiled from C to Go between 1.4 and 1.5. So that was, well, a year ago. And that work was done using, like, they built a tool to do the translation, and they have since, like, cleaned up the generated Go code. Turns out, transpiling idiomatic C into Go tend not to generate idiomatic Go. You get there's different semantics when it comes to well, not real semantics. There's different strategies you can take to how big your scopes are, how long lived your data is, and how fast you want to throw it away. So they have done some trickery where it comes to they insert closures that do nothing really, just except for just closing over parts of the code, just to speed up the end result.
I think that the cool thing there was that they had a working, fully functional, like verified compiler, but it was in C. And the way they got that working in Go was to do that. They transformed it. And then
So they didn't really write that much. Like, well, they patched like their transpiler a little bit to, well, for the edge cases, but I mean they managed to do the, well, press the button and get a new compiler in a different language, which was kind of impressive.
They had this tool they called Go Fix. They used that also before the 0.1 release to sort of iterate over the library. So when they did breaking API changes before they had a 1.0 release, they could use this tool called Go Fix to rewrite
Your own code, your application code. You can rewrite.
So you could actually have a public iteration over its deadline.
I should also mention that there's a lot of Go developers in the Gopher Slack. There's thousands and thousands of us, not active at the same time, of course, but
There's currently 7,238 members.
yeah. So there's a small app that you can go to get like invited into it, because Slack hasn't solved the public Slack domains problem yet. But we hang out in Stockholm, well, at many hours of the day. But we also have a Go meetup, Go Stockholm on meetup.com, and
Which was lastly hosted by Google.
yes, we were at Google last time, and we had like an open space where we discussed 3 by 3 topics, so 3 tracks, 3 different in each track, and that was interesting to see like how many people are interested in working with Go. So far, I haven't seen that many companies publicly talking about using Go in production, but it's getting there, and by 2020 it should be it should be in major use. And that is pretty much what I prepared for today. I haven't gone into that much of like deep technical parts of the language, but I think you got to see at least that we have some parts that we are happy with. Yeah.
Thank you.
Thanks.
Go universe.
Okay, so these are my notes. I don't usually work with slides. I don't like them, so you'll have to do with this. Most of my presentation will be mostly demo material. I'm going to give a short intro first. So I'm PSG Luna on Twitter, otherwise known as Luna Duclos. I work for a small company of 4 people called Palmstone Games, which I founded together with an American friend of mine in the US. We initially used C# and Unity, which I'm sure many of you are familiar with. When UE4 announced their amazing engine that they were going to release for free, we decided to dump Unity because there's lots of wrong with Unity. I will not go into that now. And we looked at our C# server stack and checked on, okay, do we want to keep this server stack or do we want to switch to something else as well? The conclusion ended up being that Go was a much better fit for us. The main reasons were we're deploying everything in containers, which meant that deploying the C# runtime everywhere was getting annoying. And just being able to deploy Go binaries, either statically compiled to run on Alpine, which means that the container plus the binary has a rough footprint of around 5 megabytes. That's the kernel, the OS, and the binary. Instead of Jira, for example, which is running on Alpine in our stack as well, which has a footprint of around 600 megabytes, which is, well, Java.
A factor of 100.
Yes. Okay. I have a couple of things I want to show about Go's performance, first of all, as that's the prime reason we picked Go for our server stack. This is the first one.
Is this the GC graph? No?
This is Perl. This is a Perl app that was replaced for 10 minutes with a Go equivalent. I think the graph speaks for itself.
Yeah, the service died there.
It didn't. It didn't. It was actually still running. That's the Go version. And then a couple other things that are really nice. This is garbage benchmarks for the Go garbage collector. As you can see, it used to be roughly linear in blue with Go 1.3. They improved on it in Go 1.4. And then they just went, oh, fuck this, in Go 1.5.
So what's the actual scale on the Go 1.5 there?
It's a factor of 1,000.
It's thousands times faster because what they did is they went from a stop-the-world collector, like Go 1.3 and 1.4 are just normal classical stop-the-world garbage collectors. They went to a parallel collector in Go 1.5. So it does as much work as it can in separate Go routines, and it only stops the world when it really has to. Typical pauses are 2 to 3 ms, which is for some certain type of services like real-time games, really, really awesome.
Notice also that the graph there is like in gigabytes. 20 gigabytes.
Yes,
Oh, shit,
that's
that would be
gigabytes down there.
That's like a 5 millisecond pause from 20 gigabytes.
That is not bad, not bad.
Not bad at all. Okay, and then I have another graph. This is GC pause time improvements in an actual production app with the 1.5 rollout.
I should note that the thing that made it that impressive was that they switched to having the mark phase not be connected to the sweep phase. So
Indeed.
they have a very, very, very short mark that stops the world, but then they start running again.
Yeah, and they sweep in parallel. It does, however, mean that the garbage collector can be consuming 10% of your CPU constantly. Like, it can passively use 10% of your CPU just to GC.
Well, that you can plan for.
Exactly. On the other hand, you just don't get pauses, which is amazing.
And also, Go is not a single thread. We talked about coroutines and we talked cooperative multi-threading, but it does use all the threads if you want to, all the cores on your computer, so it's not a split. So it's truly parallel.
Okay, so that's Go's performance. Another thing I really like, we're a game shop. That means we run Linux servers, and we typically run Windows clients. That also means we have UE4, that's our game client. Then we have Go. Everything except the game client is in Go. That includes game launchers, patchers, etc. Why? Because of this. The Go compiler has 2 variables. They're called GoOS and GoArch. They're just environment variables. When you set them, the compiler compiles to those architectures. That's it. That's all you have to do to cross-compile. Set two environment variables.
And as you can see, it's quite an extensive list.
And it is indeed quite an extensive list. I'm going to have to zoom out to fit it on screen.
Darwin on 386.
Yeah. Oh yeah. Why would you do that?
Go runs on almost every type of hardware these days. There's still some vague architectures that it does not run on, but they're becoming rarer and rarer as time goes, which for us means that we develop on Linux, which means we're using these to cross-compile all our binaries to Windows without having to hassle. If any of you have used GCC, you know how big a bother it is to cross-compile anything. This is much better.
And there you can see there's ARM support and then PPPC and MIPS as well.
Indeed. There is one issue with this. If you link with C code, you're back to GCC hell because your CDEPs also have to be cross-compiled. It can work, but you're back to the usual C hassle if you do that.
JavaScript wrapper.
Okay. Next thing is this. We talked about statically compiled binaries. Who here is familiar with Alpine? Okay, that means you guys run containers. Yes. You also know that Alpine is based on muzzle, does not have libc, which means any libc binary just plain out doesn't run. To fix this in Go, you just pass this flag, which entirely disables cgo and removes any libc dependencies from your binary, which just makes it magically work on Alpine without having to do anything else. Okay, ecosystem-wise, this hasn't really been discussed, so I'll go into it a little. There's GoGet. GoGet is the standard tool if you have a Go workspace, like John showed. You can just go get code, and the GoGet tool will download it for you from the Get or Mercurial or SVN repository, and dump it in your Go workspace.
So it's basically a Nugget or NPM or...
Basically, yeah. Then you have GB. GB is a separate tool. It's entirely unrelated to the Go tool. And what it does is, instead of using the environment variable called GoPath to determine where your workspace is, it does it based on your current working directory. Like checks the directory layout of your parent directories and determines where your workspace is. When is this handy? When you're working on a couple different projects that need different dependencies, or that even need different versions of the same dependency that you can't mix in the same Go path. It's quite nice in those cases. Okay, as was mentioned by Peter as well, the Go for Slack is a really great place to get Go help. There's a newbie channel if you don't want to ask your questions in the general channel because you think they're too dumb. There's also a pretty active general channel and a lot of other ancillary channels, one for Stockholm. Okay, and now onto the main course. What I wanted to talk about is Polymer. Who here is familiar with Polymer, the JavaScript framework? Okay. Go has a tool called Go4JS. Yes, once I start showing code, I will, don't worry. Go has a tool called Go4JS. Go4JS basically adds JavaScript as an extra Go arc, so you can transpile to JavaScript. Everything works, so Go routines work, channels work. It transparently switches between Go routines as you would expect. But there is nothing that doesn't work in the regular Go that doesn't work when transpiled to JS. How do I zoom this?
Control plus will work. This is Visual Studio Code.
Nope.
Okay, so that totally works.
View, zoom in. Control equals. Why? I don't know. But
No, this is
that's Visual Studio Code. Is that readable?
Yeah.
Okay, so I'm going to show the result first. Really easy example first. I have a small real-time clock. I have some HTML for it, which I'll show first. This is just typical Polymer, if anyone has used it. I import my element here. I use it here. There's just not much to explain here. And then I have the element itself, which is again just typical Polymer. I have a DOM module, a template. I have an input. Oh wait, this is the wrong one. Let's show the right code. It tends to help. Still, same thing. I have an index with the element. I have a time ticker element.
which just calls a compute time function. And then I have a little bit of Go code. For those familiar with Polymer, this shouldn't be too complicated. For those that are not, I'll try and quickly explain the basic concepts. So in Polymer, I have my tick timer element. And I say here, this is an element defined in Go. The element is called tick timer. You will find the code in the Go side. And then over in the Go side, I call register, polymer.register. The Polymer package is imported here. And I say, for tick timer, I want you to use this struct. So I just define a struct and bind it to the element. The element has to embed polymer.proto. Embedding hasn't been explained, so I'll quickly go through it. Embedding is when you take a struct, you grab all of its elements, and you make them part of your own struct. That means that your struct now implements all the interfaces that the embedded struct does, which is the important bit, has all its member variables, and all its functions.
And it's very important to say this. It does not introduce inheritance.
This is not inheritance. You can embed multiple types.
So there's no type hierarchy.
So it's composition.
Yes.
Yes, it's composition. Thank you. Okay, and I have a time member variable of the standard runtime type, time.time, and I have an attribute declaration that I forgot the proper Go name of. How are those called again?
Those are struct tags.
Struct tags, thank you.
Struct tags are also things you have access to from the standard library, so you can make your own library if you want to have.
Yeah, the Polymer library may declare their own tags, basically. This tag is called bind. What it does is exposes that variable to the JavaScript and Polymer code. So that means my HTML can actually access that variable. And then I have a created function. This is a bit dirty and very not Go-like, but the created function is automatically called by Polymer when the element is instantiated. For those that have used Polymer, that's the same as the JavaScript created hook you get. And it starts a Go routine. What does the Go routine do? It grabs current time. It notifies the UI that the variable time has changed. Why do we need to do this? In most languages, this would be automatic, because Go does not let you define any magic that will run in the background when you do something. There is no operator overloading or any kind of magic I can do at the end of the function, unlike JavaScript that has notifiers and all that kind of fancy stuff.
There are defer statements, though.
True. There are defer statements. But it wouldn't work here, I'm in a for loop. Like, random comment, don't use defer in the for loop. Seriously, don't.
So what I want to say something about with defer is kind of cool. So it's similar to a using statement, in that the intent is like a finally clause or something like that. You're supposed to do something at the end of something. And in like basic C code, like we have to do cleanup. We have to call like, okay, deallocate memory, free memory, stuff like that. This is stuff that we can say, okay, so when we're exiting this function, defer the call to this function. So we can kind of group up, clean up stuff in a defer call.
That's really cool, except if you're running an endless loop.
Yes.
Why? Because your function will never end.
Yeah, exactly, right. So, but every time you call defer, it's actually kind of queuing up a function call somewhere in a single linked list. So if you do it in a loop, you'll just...
Yeah, well, you can do it in a small loop, but in this case, this loop is endless. The function will never return, so defer is literally useless to me.
And there's another aspect of that, and that's because the way Go managed stack space and the way it managed memory, that if you really mess up, it will destroy your computer. And I'm talking about, I'm talking about you will not be able to use the computer. It will just completely grind to a halt. Because Go has the capacity to claim every piece of virtual memory available.
To explain, Go has growable stacks, which means that typically
That's
stack
one way to get around Stack Overflow.
yes, there are no Stack Overflows in Go, but Go does some sanity checking, and if you're calling the same function a million times, it's just going to throw a Stack Overflow anyway.
So this did not happen to me, and my computer froze, and I was unresponsive for an hour.
It used to be that you couldn't run it on machines with more than 128 cores and like a allocatable memory of 512 gigabytes or something like that. but
Interesting.
those limits are so
When I read about this, like the stack space limit is like 1 gigabyte. Like that's the default stack space.
does it do tape clone recursion?
No, it doesn't.
But do they need heap if they can contain everything in state?
Yes, because you can make huge arrays that are several gigabytes large. You can store those on the stack.
This is also kind of a cool thing that they do, and is that they implemented the concept of what they call escape analysis. So every allocation is assumed to be heap allocations, but then they have this step where if they can prove that the memory does not escape the function, it's going to be stack allocated.
With exceptions. Anything too large
Okay.
will
there's a
be
side-
on the heap anyway, because it's not efficient to assign 10 megabytes on the stack.
No, it doesn't make sense.
It's a waste.
Can I ask questions right away?
Of course, go ahead.
Do they have same defragmentation process?
No, they don't.
So they
But they have made it, so this is a cool thing about the garbage collector, it's not generational. It's a very different approach to garbage collection than maybe other programming environments, and this is some of the reasons why they have such good latencies. But they have made it clear that at some point they want to have a compacting collector.
Yeah.
So that they can actually deal with fragmentation.
If you link with C code, it will actually limit you as if it was a compacting collector. So if you keep pointers to Go, you will get a nice compiler error. Don't pass Go pointers to your C code, seriously. And it won't let you. But apart from that, they intend to implement compacting, as was said. Back to the program, like I was saying, I set the time in my variable. I notify the UI that I changed the time variable, and I sleep. I do this in an endless loop in a Go routine. What do you usually expect when you write an endless loop in JavaScript? You expect a hang.
That's why you don't.
Exactly. However, this just works. With Go4JS, Go routines are entirely built in, which means that when I start a Go routine, I'm running things in the background. It's still single-threaded, because running thread in JavaScript is a pain in the ass, so they don't. But
does it compile the Go routine? Does it compile to some web workers?
I don't know. I don't know what it compiles to, but it works.
can you check source code right away?
Yeah,
Yes, I can.
I think it did.
No, now I need to zoom a bit again.
And one thing I think is really cool here is
Whoa! Okay, so let's not check.
I'm sorry, Go4JS is not intended to generate readable source code. Plus, that's minified, so it's extra bad.
Oh, well, was that the top one?
Huh?
Was that the top one or the second one?
This one.
Yeah, check the second one. What is that?
This one, that's the one I should show you.
Yeah. Yeah, but the JS? Oh, yeah, right. Yeah.
Yes, the browser runs JavaScript.
JavaScript representation of the binary, well, it's going to be fairly big because, well, we have the runtime. We have the
Yeah, this is the one disadvantage of Go4JS. You get around 1 megabyte of baggage because you're including a good chunk of the standard library of Go. If that's not an issue, however, Go4JS is quite nice.
So one thing I think is kind of cool here is that time sleep is normally treated as like a blocking operation, right? We block the thread, that's how we think about it. But clearly what we're doing here is some sort of cooperative multi-threading. We're just yielding the execution to some other place. And I tend to favor cooperative multi-threading over many other types of threading. I like that. And I've tried to figure out how they did do this, but I've read something that they have this approach to I/O as well.
Correct.
That when you read a file and it goes off the operating system and waits for some operation, they're not wasting, you can use that CPU time for something else.
Correct. So what Go actually does is it decouples threads from Go routines. So you can have 1 million Go routines running on 16 threads, for example. And what it'll do is whenever one of those Go routines blocks on anything, that could be a lock or a channel read or a kernel call, disk I/O, anything, it will run another Go routine in that same thread. So Go actually has a scheduler that's bundled to every binary. That includes the JavaScript version of it, though that one's much more lightweight because it doesn't need to do all that much.
So that's the same thing like Erlang's actors do, right?
I have no idea how Erlang works, I'm sorry.
I've heard the comparisons being made with the exception that an actor has an address and goroutines do not. But yes.
So you need to provide some sort of address, well, a channel to contact the goroutine.
The goroutines can have return values, but you can pass channels in. But you cannot send channels with channels.
For the record, that also means that if you write an endless loop without any blocks, you are locking up a thread. If you're doing a busy loop or a busy block, that thread will not be doing anything else, obviously. That's especially bad if you're using Gopher.js. Why? Because it's actually single-threaded. You can see that coming. Don't do endless loops without any blocks in Gopher.js. However, in practice, that's super easy. There's so many things in Go that transparently block for you that you usually don't notice this problem. I'm going to give a short example. This is some production code for the Delta website. Delta being a game I'm working on. Yes, I need to zoom in, I know. Yes. Okay, so I have the same principle here. I'm registering the element called Delta carousel to the carousel struct. And what does this do? It's an image carousel that automatically switches between images after 10 seconds, and it pauses when you hover and all those fancy little features. And I added some Polymer behaviors. Those that are familiar with Polymer know what that is.
What's the ampersand for?
Let's
Mention that.
take a pointer of.
Okay.
So I'm just taking a pointer to
So C.
an empty carousel
No,
struct.
but this is the important thing, I think, because it's not C. And so you have memory management in some essence. And the cool thing is that if we remove the ampersand, we're really just saying this is actually a value instantiation. We're just instantiating the value of carousel. Right? So this creates a struct.
Yeah.
Then we say, give us the address of this thing. Well, that actually causes escape analysis to force this up on the heap. So this is just a way for us to say new carousel. Default constructor.
Okay, then I have my carousel element. It has a couple more things than the other one. It has the mandatory Polymer proto. It has a couple variables, a slice of strings for the images, an integer for the amount of delay I want between images in seconds, an index for the image that's currently enabled, a width, standard stuff. Then it has the interesting bits here. These are event handlers. So what Polymer Go does is that it uses Go channels and uses them to pass events along. So instead of having callback hell, like you have in typical JavaScript applications, you just have a bunch of channels that you listen to in a separate Go routine.
And we'll see a select statement for this, yes?
Yes, that's the whole point of showing this. Okay, so I have my created function that just initializes some stuff that's boring. I have my ready function, which is more interesting. It has listen mouse events and listen resize. I'm going to show listen resize first because it's the easiest one. Those that are familiar with Polymer will know what iron resize is. It's a Polymer magical thing that will tell you whenever the screen is resized, which is in JavaScript relatively hard. So window, the element itself, is actually what it's listening to. So whenever the element is resized in any way, we'll tell you. It does that depending on the browser with either the events, but most browsers don't support those. So for those, it has loop to check every X time. Anyway, that's not the important bit. The important bit is that I'm making an event channel here. Just make a new channel of the type pointer to a Polymer event. I subscribe to the iron resize event on myself, like carousel here. That's the equivalent of this in Go. I just give it a name here. This could be this, and you'd have the equivalent of how C# does it. And I subscribe to the iron resize event. I pass my channel as an argument. Then I spin up a Go routine. I spin up an endless for loop. And I listen to that channel.
But you don't care about the return.
No. In this case, I just need to know when it's resized, not exactly what size it's resized to. And then with a delay of 1 millisecond, why? Because HTML is fiddly and sometimes you need to wait 1 millisecond for it to finish doing its thing. And I calculate the bounding client rect, which is just a JavaScript function I'm calling from Go here. I grab the width. I put it in the variable width, which was defined up here with a Polymer bind, if you remember. And then I notify. What does this do? That means that when my data binding that uses the width attribute in HTML will get the new size that it computed. Now for the more complex case, mouse events. This is a carousel, which means it needs to be interacted with by the mouse. You have buttons at the bottom that you switch between images. And when you mouse over, we want to stop the image from switching to the next one, because it usually means that the current image grabbed the user's attention. So how do we do this? Well, we have 3 handlers here. We have a little bit of HTML code that I'm hoping I can show. Yes. You can see here that I have my div, and I just have event declarations here. This is just standard Polymer, for those that are not familiar with it. On mouse over, on mouse out, I just trigger the mouse over function and the mouse out function. In Go, this maps to those 2 channels rather than functions. And then, as before, I spin up a Go routine, I start an endless loop. And here I have this really interesting construct called a select. Select will block until any one of these channels signals that it has data ready. That means in a single for loop, in a single event loop, basically, I can listen to the mouse over, the mouse out, as well as the clicking on the switcheroos at the bottom to react to that. If anyone ever has used Qt or WX widgets or any kind of desktop UI toolkit, this will look really familiar. It's the exact same concept, but in a web app instead of a desktop one.
It's the same as listening as using select on network sockets.
Yes.
Pretty much, indeed.
Or wait any.
Yeah.
It's similar to wait any in C#, indeed. And they let me do cool stuff. If I look at the cancel switches function, which is interesting actually because it uses concurrency. Where is it? Cancel switches, here. Okay, so here I have a bit of tricky code. Let me explain this. What my code usually does is it spins up a Go routine, it waits X amount of seconds, and then switches to the next image. When the user hovers, I want to tell that Go routine to stop doing what it's doing and stop switching to the next image in X seconds. I use a signaling channel for that. That's a concept that does not work in normal Go code, because this would be a race if I was running more than a single thread. However, in JavaScript, this works because we're single-threaded. And what I do is, if the signaling channel is currently not nil, which means that the scheduling Go routine has scheduled the switch, I send a cancellation to that channel. This is a bit of an odd construct. You two should be familiar with this, but
Well,
everyone else, not so much.
I know the interface. This is what?
Okay. Yes.
Why she does that.
Yes. So
So I have a very interesting question there. Why not just send 1 or 0, right?
because that would take space.
An empty struct is 0 bytes.
Yes.
Okay.
Anything else is not 0 bytes. So I have this type declaration, right?
So then what's the difference between that and another paragraph?
Let me let me explain. Okay. So if I have this type, if I have this type, I can make an empty version of it here. How much bytes does an empty foo take? 0, obviously. So nothing stops me in Go from doing this. That's the same thing.
Okay, so that's
This is my type.
that should work.
This is my type, and that's the instantiation of it. That's why you see that weird construct there of I'm making an empty struct and initializing it in the same.
Which means you could have declared anything there, really.
Yes, I could have put variables in here. I can do this. I do not recommend anyone ever doing that, but you can do this
But I
if you
think
want
that
to.
speaks to kind of the simplicity because it's the same thing. It doesn't. It's not a weird syntax. It's just very
Yeah,
compact,
this is the same thing. Again.
and it will work.
And both will work, indeed. Anyway, that's an explanation of the odd construct there.
But what will that compare to in JavaScript?
I don't know. I don't know or want to know, to be fair.
Okay.
Nothing. Are you sure it will be no? That would be weird with the next line. Equals to nil. That would actually be...
Well, it's only, yeah, okay, so to explain the way Gopher.js works, I'm telling you I don't know how this compiles to JavaScript because Gopher.js is built in a way that you virtually never have to care about how it actually happens in JavaScript.
But we could actually check this.
You could check this, yes.
We could, no, because here we have actually variable names to search for in
This-
MS.
No, it mangles that as well, I'm sorry.
We'll figure it out.
But
We'll get to the bottom
if you
of it.
want, this code is open source. This is just code.palmsandgames.com/polymer. It will redirect to GitHub. It's the examples folder. You can just compile this and figure out what it outputs if you want.
What the hell, go?
There's a small README file. There's a quick start. You go into the examples folder. You call build_all.shell. And then you start Caddy. Caddy is a Go web server that will just serve any arbitrary folder. So if you check, I'm actually running it in my console here. Caddy is running on port 1215, which is what's actually serving up my examples here. That is all I wanted to talk about.
Thank you. Thank you.